inter-process communication. We are going to discuss the following topics, where we'll start with introduction to inter-process communication. Then we'll talk about the application program interface for the internet protocols. As a part of that, we'll see what are the characteristics of inter-process communication. Then we'll talk about the sockets. Then we talk about the UDP datagram communication and TCP stream communication. And then we'll talk about different external data representations and the concept of marshalling. And towards the end, we'll talk about multicast communication. As a part of that, we'll discuss IP multicast, which is an implementation of group communication. Then we'll talk about the reliability and the ordering of multicasting. So, while studying your concepts of networks or then network security and cryptography, we have a basic knowledge of what is TCP, UDP, and multicasting. So we'll extend this concept for distributed systems. So that's what we are going to discuss as a part of this particular unit. So let us start with the initial introduction to inter-process communication. So as we have discussed, in a distributed system, the process will communicate with each other through messages, and any instruction or data will be passed through messages. Okay, so the application program interface to UDP provides a message passing abstraction. So while using TCP or UDP, whatever you are using, we'll use message passing mechanism, and this is the simplest form of inter-process communication which we will be adopting as a part of this distributed system, or in general also. So in this, it enables us to send the sending process to transmit a message to a receiving process. In other words, we have to say that the client will send a message to the server. The client process will send a message to server process. Okay. In the process of communication, a set of independent packets containing these messages will be passed from sender to receiver or client to server, which are called datagrams. Okay. So in Java and Unix application program interfaces, the sender specifies the destination. Using a socket, they will specify the destination to which it wants to communicate. So when the sender wants to communicate with the receiver, or client wants to communicate with the server, the client or the sender will specify the destination to which it wants to communicate with. So as a part of that socket communication, an indirect reference will be there to a particular port. So the port with which you want to communicate. So there will be several ports that are going to be there with each of the computing machines. So the port through which you want to communicate, there will be some serial ports, parallel ports, all these things. So with which port you want to communicate, so that the necessary communication will happen. So the particular port that is going to be used by the destination is going to be specified as a part of, as an indirect reference to that particular port. You can see in the diagram, we have the UDP and TCP at the bottom layer, and there are two middle level layers, which consists of the inter-process communication primitives, sockets, the message passing mechanism, or support for multicasting or overlay networks. And above that, we have the remote invocation and indirect communication. Okay, and we have the applications and services at the top. So in this particular diagram, whatever we are showing, the middle layers, that is inter-process communication primitives, sockets, message passing mechanism, multicast support, and the remote invocation and indirect communication are nothing but the middle layers. And the bottom layer is the UCP and TCP, which is the communication protocols. and above we are having the applications and services. So the communication will happen between using the middleware layers from the application server through UDP and TCP. So coming to the application program interface to TCP, it provides a two-way stream between the pairs of processes because you have to provide the communication from one to client to server, okay, and server to client. Both a communication, two-way streaming is required. So here I'm using the word stream. So the data or message transmission that is going to happen in terms of streams of data, okay, without any boundaries. That means it's a continuous communication that is going to happen between the set of processes or pair of processes. Okay, so here the concept of producer and consumer. So producer means who is communicating, and consumer is nothing but who is receiving. So these two processes, whatever you are talking about, these processes should be in such a way that means if you have the speed at which the stream of data that is coming from producer, with the same speed the consumer should consume that particular data. That means should be able to receive the data. Okay. So in the process of doing that, all the messages will be queued. They will be passed through a queue, and at the receiving end, when the consumer is ready to receive them, he'll start receiving. Okay. So to do so, what we require is the consumer has to wait when there are no data items, and the producer must wait if the storage used to hold the queue data is exhausted. Now, here you must remember one thing: the memory that is going to be used for queue, there will be some limitations. Okay, there will be some limitations at the producer end. So when he is passing the data through the queue, once the queue is full, then he has to wait because he can't send any more data. He can't send any more data. So the consumer, 2 points you have to remember here. The consumer must wait when there is no data items that are available for consuming. That means the queue is empty. So the consumer has to wait till the next block of or next stream of data is coming in. Okay, and in the same way, the producer must wait if the storage used to hold the queued data is exhausted. That means I'm placing a stream of data on the queue. So if the queue is full, the producer has to wait. So I can't pass any more messages because the queue is full. So once the queue is transferred to the consumer, then the queue will be empty, or empty spaces will be there in the queue, so that I can send another block of data through that particular queue. So this is what that is going to happen by confirming message passing or data communication that is happening between two processes using TCP. So as a part of this communication, there are several things that we have to discuss, or that we are going to discuss in this particular next few slides. So that is nothing but how the objects and the data structures that are used in this particular programs, which can be translated into a form suitable for sending messages to our network. So how the objects are going to be, what are the data structures we are going to use, and how they can be translated so that they can be sent as a messages over the network. So this is the basic aspect that we have to discuss. And second part of it is when the multicast communication, that means multicasting is happening, where one process in a group of processes transmits the same message to all the members. Multicasting is a process will send message or transmits the same message to all the members of the group. That is called multicasting. So how this multicasting communication is happening, has to happen, that also we are going to discuss. And we are going to talk about the overlay network. Overlay network is nothing but it is a network built over another network so that it will permit the applications to route the message to destinations which are not specified by an IP address. Okay, that means it is a network that is built over another network, that is called overlay network. So as a part of that, we have to permit the applications to route the messages to destinations which are not specified by an local IP address. So these are the aspects basing on which we'll be discussing further in this particular unit. So as we have discussed, message passing between a pair of processes is going to be supported by two message communication operations. That is, basically we'll have two operations that will perform this particular communication. That is nothing but send and receive. Send and receive. So these are the messages which are defined in terms of destinations and the messages that we are passing. Okay. So as a client, I want to send a message, and that message will be received by the other process or server process, and it is vice versa. As a result of the processing, the server wants to communicate with the client also. Okay, so I want to execute some process at the another process. So I want to execute a process at the other process. So in that case, I will be the client and that process will be the server. As a client, I will communicate with that process, which is nothing but called as a server. And in turn, the server may result in with the result, which will also be communicated to the communication. That means the message passing is going to be vice versa, two-way directional. Okay. So as a part of that, even the server process wants to communicate with the client. So in that case, the server is the sender and I will be the receiver. That's why most of the discussion, whatever we are going to do now, most of the discussion which we are going to do now, all the places will be using the word send and receivers, sender and receiver. Instead of using client and server, we'll use the terms sender and receiver. So sender means the process which wants to send the message, and receiver is nothing but the destination to which the message should reach, and the destination should receive that particular message. So that's what it says. To communicate, one process sends a message. One process sends a message, which is nothing but message consisting of a sequence of bytes. Message consists of a sequence of bytes which will be passed to a destination, and another process at the destination receives the message. So another process at the destination, another process, be clear here. So destination is a physical location or a computer or any other device which will receive the message through the that computer. A process of that particular process which is executing on that particular destination will receive the message. That's why it is said destination sends a message to a destination, and another process at destination receives that particular message. So this activity, whatever we are talking about, is nothing but the communication of data from sending process to receiving process. In the process of doing that, we need to maintain the synchronization of transfer of data. We need to talk about, or we need to discuss about the synchronization among these processes. So why we require synchronization? Because both the systems which are communicating, so there is a computer A and computer B, which are in distributed system, and the computer A is the sender and B is the receiver. It means that the communication is not happening between the computers. Actually, the communication is happening between two processes which are executing on which are executing on two different computers. So even the physical communication is happening between the computers. Actual communication is expected to be between processes. A process which is executing on computer A will send a message, and that should be received by a process which is getting executed on computer B. Then computer A is called source and computer B is called destination. So here, whatever you are saying, sender and receiver, they are the processes which are executing on two different systems. Okay. So this process of, because as they are executing on different environments, each of the process which are getting executed on different computers may have different speeds of accessing. The speed at which the computer A sends, or the process which is executing on computer A sends, with the same speed, the process which is getting executed on the system B may not receive. Okay, in that case, we need to maintain a synchronization. So, if they are working in synchronous, there are no much issues. If they are synchronous communication, there are no much issues. But if they are asynchronous in nature, then we need to have some discussion on that. Whatever I'm sending, if it is receiving with the same speed, only the network is the issue here. If they are not of the same speed, then in addition to the network speed, we have some other issues that are also required to be discussed. So there are several aspects that are to be discussed for communication between two processes which are executing on different machines when there is a communication that is happening between those particular processes. So here we are going to talk about both synchronous and asynchronous communication. So now what we are going to do is we are going to discuss what are the issues that what are the issues that are going to be there as a part of this communication, and which aspects are to be, what are the basic characteristics that particular communication should have. That's what we are going to have. We are going to discuss now. So here, as I said, whenever the communication is happening, a sequence of messages will be made part of the queue, so that they will be going in the form of a queue and received at the receiver end. So a queue is associated with each message destination. So when I want to send a message to a particular destination, there is a queue which is associated with each message destination. So sending process cause messages to be added to the remote queues. So the queues which are there remotely, so through those queues, the process which is sending will add those messages to the remote queue, and the receiving process removes messages from the local queue. Okay, so those particular messages will be brought into the local queue of the receiving end. Okay, so this sort of communication between the sending and receiving process may be synchronous or asynchronous. As I told you, if it is synchronous, what we are going to talk about. So it's very simple. So when it is synchronous form of communication, as we know that synchronous means both the sender is sending with the same speed as the receiver can receive. The sender is sending the messages with the same speed as that of receiver can receive. Okay, so as a part of that, both the sender and receive are blocking operation. That means whenever a sender is issuing a send process, is blocked until the corresponding device is corresponding receiver receives that particular information. Whenever the receiver receives that information, automatically the receiver unblocks the communication, so that the sender will send another block of data. So in synchronous form of communication, what will happen is, once again I am repeating, once a block of data is passed to the sender is blocked until the receiver receives the information and unblocks the communication. So whenever a receive is issued by a process or thread, it blocks until the message is arrived. So this is called synchronous form of communication. So in synchronous form of communication, whenever sender sends a block of data, automatically it will block until the receiver receives the data. So when the receiver receives the data, once again the communication will be unblocked so that another block of data can be transferred. Now, so that's what we have to take care of when you are having synchronous communication. So in synchronous communication, for each block of message that is passed through the communication until it is received at the receiving end, the sender is being blocked. But in asynchronous form of communication, the way of dealing is somewhat different. The use of the send operation is non-blocking in the sending process, and in the sending process is allowed to proceed as soon as the message has been copied to the local buffer. It is first thing is non-blocking. It is non-blocking in nature. And one in this sending process is allowed to proceed as soon as the message has been copied to local buffer, and the transmission of the message proceeds in parallel with the sending process. Okay. So the sender will place a block of data on the local buffer, and it becomes ready to send the another block of data. But the receiving operation can have either blocking or non-blocking variants. In non-blocking, the receiving process proceeds with its program after issuing a receive operation. So first it tries to receive the data. If it is non-blocking, I'm telling you, and the buffer provided is filled in the background, the receive notification that its buffer has been filled. So what will happen now is, now it has to go for either polling or interrupt mode. So when you say interrupt mode, that means it has to interrupt the process for sending. Now the receiver will interrupt the process to send another block of data. Okay. So in this, there is a one block is being received at the receiving end. So automatically what will happen? The receiver has to block the sender from sending another block of data. Okay. So because this is non-blocking, now it has to go into interrupt. It has to interrupt the operation. Now in blocking receive, one thread can issue while other threads are in the process remain active. So because every process may have several threads, and if every process will have set of threads, one thread will issue while other threads in the process remain active, and simplicity of synchronizing receiving threads with incoming messages is substantially guaranteed. So that means other threads can. So here you must remember one thing: when you have multiple threads, every thread will have its own block of message or message buffer, so that other thread of the particular process maybe is still active and its input buffer is available, so that another block of data can be received by that particular other thread. Okay. And non-blocking communication is appears to be more efficient But here you can see it involves extra complexity in the receiving process associated with the need to acquire the incoming message out of its flow of control. So that's what I'm saying. So whenever it is filled with the buffer, when the block of data is received, it has to control the incoming messages so that it won't go out of control. It won't go out of control. So in non-blocking communication, the receiver process, if it is capable of receiving multiple blocks of data simultaneously, then it is definitely advantageous. Otherwise, there should be a mechanism which is complex in nature, that is nothing but controlling the flow of control, controlling the flow of data. So that is why it is somewhat complex in nature, but it is definitely more efficient. Non-blocking way of communication. Non-blocking way of communication, specifically in asynchronous communication. In asynchronous communication, non-blocking way of communication is more efficient, but it requires a complex approach in which we have to maintain or control the flow of data. Okay, so because of this complex nature, because controlling the flow of data is very tedious in nature, that's why most of the current day systems generally doesn't provide non-blocking form of receiving. So still they will go for blocking way of receiving. Even the blocking way of receiving it may not be that much efficient, but it is very easy to implement. It is not inefficient. It is not that high efficient than your non-blocking. Blocking receive is, you can see here, that's why specifically I have mentioned, blocking receive has no disadvantages. So here I'm not saying that it is more efficient than non-blocking. Definitely non-blocking communication is more efficient. Let us assume that there is a stream of flow, water flow that is going, and the sink which is accepting the data is sufficient enough to accept it with a faster rate. Then there is no way of doing, there is no requirement of breaking the flow of data and sending blocks of data, sending a normal flow of data. So when it is communicated, when it is able to capture all the things which I am sending, then without any blocking of data, I can send it. If it is unable to receive, then what I have to do, I have to, the stream of data which I am sending should be in a controllable manner so that it can consume. It can consume. Now, there is another aspect that is to be remembered here, the message destination. So what is message destination? The receiver is nothing but the message destination. So how we are going to specify the message destination? It may be based on the address of the computer on which the receiving process is running. Address of the receiving process, address of the system on which the receiving the process is running. So when you are communicating with an distributed system, set of processes which are executing on distributed systems, they may be far away from each other. Then we have to use the internet protocols so that messages that are going to be sent on this particular network systems, where we are going to specify the internet address and the local port. So when you are communicating with a faraway system, then basing on the internet address and the port on that particular system, the port both are required to be specified. So the destination address is nothing but the internet address and the local port. the port through which you want to communicate with the process. So as I told you, there are several ports. It can be serial port, parallel port, or whatever you have. Okay. So a local port is nothing but the message destination within a computer. That's what it says, which is represented using an integer, which is represented as an integer as a part of Internet Protocol. Okay. So this port has exactly one receiver. So except multicast ports. So I'm not talking about I'm talking about unicast. That means I'm communicating a sender to a receiver. So that means it's a one-to-one communication. I'm not talking about multicasting. I'm talking about unicasting. Unicasting. So one-to-one communication I'm talking about. So that's why the receiving end, there will be only one receiver which is specified by its address and the port. The port number is going to be represented in an integer number, and which is along with your internet address. You are going to specify the port number to which you want to communicate. And as I told you, there will be several ports. A process may use multiple ports to receive the message. So each port may be used to communicate with one process. Okay, simultaneously. Okay, so normally these particular whatever we talk about port numbers. These port numbers you may not be knowing individually, and especially the server ports. Servers normally they won't specify the port numbers of their particular server computer, and as a client you may not know those port numbers. So these particular addresses, whatever you are specifying, the internet addresses. Client uses a fixed internet address to refer to a service, and that service must always run on that same computer for its address to remain valid. So let us assume that a particular server computer is there to which you want to communicate. So in that particular case, each port that is there on the server computer should be given with a particular address or a value, and on that particular address or value only that particular service should run, so that that address will become valid. So all the time, if you are communicating, if you want to communicate with that port of the server, then that address, internet address, should refer to the particular service of the port, so that we can access the particular port or communicate with that particular port. So by which, in that case, what we require, the port number or the ID that is going to be given to that port cannot be changed. But if you are just keep on communicating with the same port number, then it may be vulnerable. Vulnerable in the sense, if you keep on communicating with the same port without changing the port number, and if you come to know about that particular port number, then there is a very possibility of some mischievous activity. So instead of maintaining the same port number, instead of providing the port number, we can go for using a service where we call it as a name server or binder. Name server or binder. So the names, every port will be given with a name instead of giving the physical number of the particular port. So what this name server or binder will do, it will translate their names into the server locations at the runtime. So that means the name server or the binder, what they will do is they will refer to the services in terms of names than numbers, port numbers. So port numbers are fixed, but instead of providing the number of the port, we will provide a name for the particular service to access that particular port. So this naming service or name service or binder will allow you to relocate the services, so that whenever the port is corrupted or port is changed. Instead of changing the so if you are communicating with the port number should not be changed. But when you are communicating through the name of the port, so the name of the port means every name of the port is associated with a port number. Now, even if I have changed the port number, if I am mapping the new port number to the name, so automatically the communication will happen. So name servers and binders will support in providing names to each of the ports. Instead of revealing the port number, they will tell you the name of the port through which you can communicate. Where unless without you can use the name of the port so that you can communicate with them. And another characteristic that we have to talk about is reliability. So reliability is going to be defined in terms of validity and integrity. So what is validity means? So reliable communication. If you want to say that the communication that is happening is reliable, that means whatever messages that you are passing, point to messages, if the message is guaranteed to be delivered despite the packets that are passing through that particular transmission are being dropped or lost. Okay, so then you can say that means the communication should guarantee that there will be minimal loss of packets. Okay, so even I said reasonable here, this should be minimal. That means no packet should be dropped or lost. Then you will say that it is completely reliable. It is completely reliable. When you are making a point-to-point message passing, there should not be any loss or drop of messages. Then you will say that the particular communication is reliable. So if it is, then when we will say that it is unreliable, if messages are not guaranteed to be delivered in the face of even a single packet dropped or lost. That's what I'm talking about. Not even a single packet or should be dropped or lost. So for integrity, messages must arrive uncorrupted and without duplication. So all the packets, whatever I'm sending, none of them should be dropped or lost, and they should reach the destination. They should reach the destination without being corrupted or duplication. Without being corrupted or duplication. So why without duplication? Because when you are duplicating the message, that means it is also a wrong message. So the message, once the message is being duplicated or part of the message is duplicated, that means it is an improper message. So in this a communication, a point-to-point message communication should be reliable. When you will say reliable, when the message doesn't being any part of the message is not being dropped or part of the message is not lost, and messages will arrive the destination without any corruption. That means they should be uncorrupted and no duplication should exist. So then the particular communication is said to be reliable communication. And another aspect also that is to be remembered, that is ordering of the messages. So ordering of the messages is nothing but whenever you are sending the messages, the order in which the messages are being transmitted from the sender, the same order it should be received at the receiving end. So if any change in the order is once again a failure. That means if the ordering of the messages in which the sender sends in the same order, the receiver should receive. Otherwise, it is also said to be a failure of the particular application. So these are the major aspects that we have to talk about. So I'll just stop here for today. Tomorrow we'll talk about sockets. So if you have any doubts, you can ask me now.